Guys, this is gonna be dope. On a long run, we're gonna have, imagine if we had 4 hours revision. Do you understand what I'm saying? Okay, now after the whole, so okay, let me make it to be comfortable, because uh after the whole where did I put that thing? After the whole intro, then we can say we have started. But anyway, you're gonna get used to it also, guys. It won't mean anything after a week. So here we go. I got it wrong. It's not the one. I
Simplified, or a set of guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Now it is recording, I believe. Yeah. Now it is. Okay. Now, if you if you talk, your freedom is your freedom. Now we are. I don't know why you think of this as an FM in Lahore. It's still us, me and you, but on Zoom, which I'm still in control of the whole meeting. But anyway, so 5.1. Last time we did the whole Cartesian plane thing to guide us as to which quadrant it is. First quadrant, second quadrant, third quadrant, and fourth quadrant. Of which, for a question like that, and Wabona, it's always loaded, that type of question. It's always 6 marks all the time. It's always 6 marks, such that if you can count the first and the second one and you get both the marks, you already have 10 marks, and it counts a lot. So sharp. Let's go back to that Cartesian plane that we talked about. I'm gonna construct it as fast as I can, because we are trying to finish the whole question before our conclusion. So as we said, when we calculate, when we number our angles around a Cartesian plane, we start from 0 degrees, and then we have 90 degrees there, and then we have 180 degrees here, and then we have 270 degrees here, and then when we come back, that's when we have 360 degrees. And then first quadrant as normal, second quadrant as normal, third quadrant as normal, and fourth quadrant as normal on our quadrant. And then the most important part is to remember that the first quadrant, we call it, it's either we say 90 degrees minus x. Let me just get a reasonable color there. So we'd say this is 90 degrees minus x. Second quadrant, because, okay, we say it's 90 degrees minus x because when you go to that direction, you are subtracting anything beyond, anything below 90. So if we're to count that quadrant, if we're to count our angles, we'll start from 0, 1 degree, 2 degree, 3 degree, up until 89 degrees. So everything there is between 0 and 89, hence is 90 minus whatever value it may be to end up being on that quadrant. I don't even have to explain this part, because I think it was all of you when we did this lesson. I'm just trying to make sure, Hore, there's 1%, like I'm not missing anyone. But when I look at whoever who's here, I feel like every one of you did. But anyway, here we have 90 plus x. Here we have also 180 minus x. 180 minus x. Here we have 180 plus x. Here we have 180 minus, 270 minus x. I'm just filling in now. Then here we have 360 minus x as well as 270 plus x. So that's what you use to simplify this. And as they are, we take them the way they are. For instance, tan of 108 minus. So we know that in terms of how we treat our Cartesian plane, all our identities, they are all positive here. And we know that on the second quadrant, only sine and its reciprocal, which is cosec, which are positive there. On the third quadrant is tan, and on the fourth quadrant, we have cos. At the end of the day, that 180 that opens up on the paragraph, it doesn't represent anything. It doesn't play a role as such. It only works to direct you which quadrant are you looking at. And then you write the identity as it is. For 180 and 360, they remain as they are. Like for instance, if you have sine 180 degrees minus x, for instance, this would be the same as, so that 180, the way I say it doesn't play a role, it directs you as to which quadrant am I looking at. So 108 is going to be the second quadrant because you see it there. So that's when you just write it as sine x and write it as positive because sine is positive at the second quadrant. Da, 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 da. So meaning that's how we take it out from there. So if we have tan 108 minus x, that would then become, wait, I'm tempted to ask, is it going to be positive or negative?
Negative.
Negative, okay. Sorry, man. Dude, okay, you know what? You know what? If I record something, maybe the way these things work, you can say, "I dog, you must delete that. You must delete that part." Because look, we are still in control of all these things. But anyway, anyway, maybe I shouldn't have been honest. Mara, you have to be honest to people because of the Poppy Act. Mara, also, it doesn't really matter, man. So 10x, and I'm not even gonna say what am I talking about. So it's gonna be negative 10x. And then we have 360. So for 360, cos 360 plus x. 360 plus, I forgot to mention 360 plus, but you know where it is. 360 plus, after you have 360 minus on the third quadrant, when you go now to the first quadrant again, that's when you have 360 plus x. And on 360 plus, everything remains positive because everything is positive at the first quadrant. So that's when we're going to have cos of x all over 2. Now, before I go on the next one, on that part, we have cos of 90 degrees plus x. Cos of 90 degrees plus x. Remember last time we said there's something special regarding cos. We said cos changes and becomes sine if it's 90 degrees plus. Sine becomes cos if it's 90 degrees plus. But within those changes, you still consider the quadrant where it is. Like for instance, look at this one. Cos of 90 degrees plus x is on the second quadrant according to our knowledge. And at the second quadrant, we know cos is negative because only sine is positive there. Sharp. Cos of 90 is supposed to change and becomes sine x because cos becomes sine in terms of 90. But as much as it becomes sine, since it was cos first place and cos was on the fourth quadrant, it should have been negative from the beginning. So that's why we say this is minus sine x. So for that one there, we would have minus sine x, just like that. And then from here, everything is just gonna unfold as you go. Just as it is gonna unfold, or it's gonna unfold, unfold, unfold. So what you see here is you have that condition where you can write tan x as sin x over cos x, of which I have as many options as I have to first deal with the tan part or deal with the signs, because I have a negative on the numerator and I have a negative on the denominator. I know that these negatives are going to get rid of each other anyway. So I can put my second step as negative sin x over cos x times cos x all over negative 2 sin x. I hope we all follow. Like I say, I'm at a state where I'm even scared to ask Corey, what do you guys think? Because I'm like, hey, fella, and then another thing, voice note maybe. So, voicemail, I mean. So now, if you can see here that this course will cancel this course because it is a fraction somehow, because this is over 1 in another world, or even in this world. It's just that we don't write the 1 on the bottom, but that's how it looks like. Now, here's an interesting part. An interesting part is that, let me put an equal sign here just to show you. After you remove the cos, you are left with minus, or let me use the same color just to keep up. You are left with the minus sin x, the one on top, over minus 2 sin x. Now it is becoming clear, because from here, your final answer is now visible, because the sign will cancel the sign. Also, the negative will cancel the negative. So you're just going to be left with 1 over 2. I know that a lot of you would have gotten that one right. Guys, for the fun of it, okay, I'm not going to laugh anymore. I'm tired of laughing. No more laughing. If you want to ask me a question and you feel bad about asking me a question here, you can type it on WhatsApp. I'll pick it up. I'm not going to mention. I'm just going to explain whatever question you ask. So if you have any question, just type it on WhatsApp. I'm going to put my phone next to me. Like, while I'm doing this, I'm going to be looking at my phone. So if you have a question, just type it on WhatsApp. Otherwise, feel free to just say whatever question you may have. I'm just saying, like, now we are accommodating vegetarians and people who eat meat and people who are afraid to talk and people who are not afraid to talk. Like, we're accommodating everyone. So the next one, 5.2, is, dude, when a question like this, you do not want to get a question like this wrong, because it's one of the few questions where your answer is already given. There's a case you could be working out something that is challenging. Yes, we understand, it makes sense. But in a question like this, you are given the information. So for 5.2.1, you are required to prove the identity above. So you are proving if the left-hand side is equals to the right-hand side. For them to say you must prove, at the grade of your level, it is like that. They are not lying. If you try to solve it and it doesn't happen to be exactly like that, then it means your answer is somehow wrong, because you're gonna get to university level and you're gonna enjoy questions like this, because while you prove if it's wrong or right, you have to be confident even when it's wrong and challenge it and say, no, the left-hand side is not equals to the right-hand side. So I can't prove that you guys are telling the truth or not. But at the moment, you don't have that freedom, because when we look at the question paper, we look at it as source of marks. Now, just know, if you had to prove that the left-hand side is equals to the right-hand side all the time, and sometimes you will go for the complicated side, obviously. Sometimes you will have one side that is complicated and you're going to prove it, and it's going to automatically be equals to the other side. Other times, you may have to prove the left-hand side halfway, and then you prove the right-hand side halfway. But whatever you do, your conclusion is to get to a point where you would say the right-hand side is equals to the left hand. Oh, I don't know. Depending on how your screen is facing, let me say the left-hand side is equals to the right-hand side. Maybe I'm going to put it directly. I don't know if you guys are using the mirror image or not, but that's your final goal. You can't get it wrong. So, and there's even a way which we must write this question, like which we must answer this question properly. You don't just go and and give them the information, because remember, you want to impress the guy who's giving you the marks. Because if you don't impress the guy who's giving you the mark, as much as I'm that person who's loud about not liking other teachers the way they do things, but they are the ones who are marking your script. So you must give them the information as it is. So you must do this. You say proof, and then you put 2 dots like that. That's how you answer a question of, so you're going to do your 5.2.1, and then you write proof, and then you put it like that, because you are proving, so you are showing your proof. So you say from your proof, we can start with the most complicated side, which is the left-hand side. So your proof is that the left-hand side is equals to, and then you write the left-hand side as is given, sine x minus 2 sine theta cos theta all over 2 cos squared theta plus cos theta minus 1. Right. While we prove, there are other facts that we know about a couple of things. I'm going to write them on the side here. Some of the things that we know is that when we have sine squared theta plus cos squared theta, we know that this gives us 1 all the time. And the moment we know that, it opens other cans. It opens other cans of worms. You can say, you can write this in the form of sine squared theta. You can take cos theta and put it on the other side and have 1 minus cos squared theta. And you can also write cos squared theta the other way around as 1 minus sine squared theta. So you see, that's how you can play with just this one rule. This one rule has given you 3 expressions that you can say about the squared part. So when you, it gives you another views. Like when you see 1, you are happy because you can write 1 as that huge thing there. Somewhere there, I see 1. I don't know how we're gonna use that 1, but we don't care. We'll see. But also on the right-hand side, we see 1. So we don't know. Like it's one of those things that even before we start, we already know. I was gonna add the 1 for cos, but when I look there, I don't see anything that can make me think of cos. Now, whatever I do, I don't even, as much as I'm chasing the question to look like the right-hand side, I pretend as if I don't know what the right-hand side looks like. I'm just simplifying the way I know how to simplify. For what's happened, it's going to happen after. What I'm doing at the moment, I'm just simplifying. So when I simplify, on the numerator, I have a common factor. My common factor on the numerator is sine. So my common factor is sine. Hey, why do I even write the other one as theta and the other one as x, and no one is going to say anything? Okay, no one is going to say anything, obviously. So we have sine theta there, and we have sine theta here, which is the common factor. And then I'm going to take my common factor out on the numerator. On the denominator, I don't really have a common factor because I have cos squared, I have cos, and then I have 1. And that doesn't it doesn't apply anymore in the form of a numerator of any some sort. So if I take out the denominator, if I take out my common factor on the numerator, I would have that sine theta. If I take out the, I would be left with 1 minus 2 cos squared. No, not cos squared, just cos theta. Over the denominator. Guys, do you see what's happening on the denominator? Or am I the only one who's seeing it? Okay. Okay. So we have 2 cos squared theta plus cos theta minus 1. I wanted to say, doesn't that looks like a quadratic function that would be in the form of 2x squared plus x minus 1? You me, guys, don't you think these two things look similar? Yes, no. They do look similar, right? Do you think if we were to try, there are different methods to approach this. If we were to try to factorize this in terms of cost, do you think it would work? Because what if I say, I don't know, we are putting our minds together now. I'm gonna do the other method after. What if I say I put my brackets and I say for the factor of 1, it's gonna be 1 and 1. For the factor of cos 2 cos squared x, is gonna be 2 cos, it's gonna be 2 cos theta and cos theta. I don't know why I keep on saying x. Now, here's the thing. I can put positive here, I can put negative here, because when you multiply 2 cos with that, it must subtract with the other one to end up getting the middle one. So positive 2 cos minus cos theta is going to give us that. We just factorize that thing, dog. I think we just factorize that thing. But that's another method, ne? Another way of breaking that part out, we can also look at it like this. I'm still on the denominator there, by the way. We can also look at it like this. I can say I have 2 cos squared theta plus cos theta minus sine squared theta plus cos squared theta, which is 1, right? Right. And then we have 2 cos squared theta plus cos theta minus sine squared theta minus cos squared theta. And then something is going to happen there, because this and that will cancel. So you'll end up having cos squared theta minus sine squared theta plus cos theta. And I think you can see where this is going. As much as I have a negative, as much as this gives me a negative somehow, remember the right hand side, I have cos plus 1. So I can put that part maybe on the denominator. So which one do we put? The factorized one or the bottom one? Or it doesn't matter? I thought we were going to discuss this part, but hey, it's not working. So the bottom part, or because as much as we want to achieve this, And somewhere here we have a minus instead of a plus. And if I already see my answer. It's just that I'm trying to discuss. But anyway, let me take this. Okay, let me take the factorized one and put 2 cos theta minus 1 into cos theta plus 1. Sharp. Let me take that one. Let me remove this nyaga nyaga because you guys, you don't care about the other steps. It seems maybe we're gonna talk about this later. Okay, sharp. Also, fact that the fact that no one can ask questions for now. You can also take your question down and ask me when we do our one-on-one later. That also gonna work. You can take whatever question you may have, tick it down, write it on the side for yourself, and then when we do one-on-one, you're gonna ask me about that question. But look at this. I'm expecting something to cancel. When I look at the top part, I have 1 minus 2 cos theta. When I look at the bottom part, I have 2 cos theta minus 1. And I'm like, ish, these things, they are almost the same, but they are not really the same. And the only difference there is the sign. So it's either I manipulate a sign on the top one to make it look like the sign on the bottom one. So I feel like the bottom one would be easier if I can take out negative on this on this thingy and end up having 1 minus 2 cos theta on the bottom one rather. So that's what I'm gonna do exactly on that one, to manipulate it to look like the top one, because I can see the answer value, it needs that negative, because where are we going to get that other negative on the right-hand side? Where is it going to come from? So I'm going to say we then have sine of theta into 1 minus 2 cos of theta all over. And then I'm going to take out the negative out there. When I take out the negative out there, it will be minus 1 minus 2 cos theta, and then the other part, cos theta plus 1, the factorized part. Aha. We have cooked our meal, because this will now get rid of that one. If you guys if you guys, your voices were working properly today, you didn't have flu, okay? If you're talking, you could see where the answer is going. But we're done, right? We're done from here, because that's your left-hand side, because your sign is going to be minus sine of theta over cos of theta plus 1. But unfortunately, no one has a mouth to agree. And then we have proved that the left-hand side is equals to the right-hand side. And the most important part is, for some reason, this statement has a mark. You do get a mark for saying this, because the question was prove to us. So you did say, as I'm saying, you write it exactly in that order, because guys, sometimes, when we do the online thing, I've realized for some students, they know how to get answers, but the way they put their information down, that's what makes a lot of people to lose marks. So you find out you would have done well in an exam, because if you look, you've got probably all the answers correct, but the steps of how you are writing every step by step, it gets up to mess up your work, because some of the things you don't even have to get to monitor at all. As much as I say, send me a picture of whatever you wrote on WhatsApp, when that picture, I feel like it would be just a scribbling of how you understand. So I feel like going forward from now, we must also emphasize as to put your steps like this, so it can be, because remember, though, all in all, your goal is to win marks. And if your goal is to win marks, you want to impress that guy to feel like, yeah, the person is doing the right thing. So just follow the steps. Like sometimes I will say, well, this one, put it like this. Sometimes there are some where there's only one way to put them. So yeah, You're gonna say proof, and then you say left-hand side, exactly as it is. Proof dot dot left-hand side is equals to, and then you put the expression of the left-hand side as it is. Then you do step number one, step number two. Well, okay, from here, however way you do it, it doesn't really matter because a couple of people can do it in different forms. That's why I said I could have done the other method, but I just feel like, no one is interested. So I felt like, let's just do the one that is easier. But my worry is if you were alone, were you gonna be able to pick it up that this is the quadratic function, like this is a quadratic equation of some sort? Nah. Again, I know, Huri, you might not be confident to answer the question right now. Put it as a note somewhere, and then we'll talk about how trigonometric identities ends up looking like they end up looking like quadratic function in a way. It's like when we do number patterns and then we get a quadratic pattern, which is about an squared plus bn plus c. So it's just the first term must be squared, the second term must just da, 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 and then the third term must just be a constant. That's how it works, clearly. But story for another day. We're good, ne? Guys, the next question for 5 marks, for which values of theta will the identity be undefined? For which values of theta will the identity be undefined? You know what? I'm going to stop recording. I want us to talk. For which values of theta is this going to be 0? The nice thing is, I'm not lying when I say I'm going to stop recording. You can hear it. Great. For now, I just want us to talk. When I go back, I will tell you when I record again. For now, let's stop and talk. What do you think they mean when they say we must for which values of theta will the identity be undefined? Anyone? Hello. We are back to reality. We have landed back to planet Earth. What do they mean by the part where it's undefined? Okay, let me unmute your mics.
Something like the nature.
The thing is, sometimes I don't. Sorry.
Like, is it like a
No,
question that
I don't really want the definition. I just ask like if we like for us to get the values of theta, it's somehow say we need to get the value of an angle where that identity that we prove. Normally we sometimes have this question. I sometimes ask you guys, what is one defined? What is one defined? And you would say undefined, something like that. And the reason would be anything that you calculate on a calculator and your calculator displays an error. We say it's undefined, right? So let's talk, right? You know what? You know what? Let me give you
Is it when
5
theta is less
minutes.
than
Let me give you 5 minutes to try it. We're gonna come back now.
Okay.
It's gonna be
I'm asking if it's when theta is less than 0.
we're gonna vote you. We're gonna vote you. We're gonna vote you for president. But if it's right, you said something 0, and I heard something distance.
So I said when theta is less than 0.
You can repeat exactly what you said, Kumu.
When theta is less than 0.
The denominator is less than 0. Oh, you know.
No, when theta is less
So
than 0.
when you're saying when theta is less than
0.
like this, is
Yes.
theta less than 0.
Yes.
You know you can write on the screen on the side. This is what you're saying.
Yes. Yes.
So when theta is less than 0, okay. Now when theta is less than 0 is there. Because when you say when theta is less than 0, you are saying when theta is negative. So when saying we can say cos of minus theta, is that what you're saying?
I don't know.
Fair answer. Fair answer. You see, answers like that, they're acceptable, man. Normally, what would make 1 over x to be undefined?
If x was 0,
If x was 0. If x